Hi! So in this video, we would like to talk a little bit about Bernoulli's principle and its application in everyday life. Now what is Bernoulli's principle, you may ask? Bernoulli's principle states that when the velocity of a fluid increases, the pressure in the fluid decreases and vice versa. Now moving on to our first application of Bernoulli's principle in daily life, which is in airplanes. Have you ever wondered how airplanes are capable of flying in the air despite being very heavy? It is all thanks to Bernoulli's principle that this very airplane is able to take flight. Now allow me to further explain this. Before we want to understand how airplane works, we first need to know about lift force. Lift is a force that directly opposes the weight of an airplane and holds the airplane in the air. Basically, it is the force that enables an airplane to be lifted up into the air. Lift is generated by every part of the airplane, but most of the lift on a normal airliner is generated by the wings. Lift is a mechanical aerodynamic force produced by the motion of the airplane through the air. The wings of an airplane have an aerofoil shape which causes air to flow at a different speed past the top section and the bottom section. The wings are shaped to make air move faster over the top of the wings, and according to Bernoulli's principle, when air moves faster, the pressure of the air decreases. So the pressure on top of the wing is less than the pressure on the bottom of the wing. This difference in pressure produces a lift force acting upwards on the airplane, which enables the wings to be lifted up into the air. The total lift force acting on the airplane is also affected by the angle of attack, as shown here. When the aerofoil is at a certain angle of attack, the aerofoil exerts a force on the airflow. According to Newton's third law of motion, a reaction force will act on the wing of the airplane and contribute to the lift force that acts on the airplane.
To prove the Bernoulli's principle, first and foremost take a piece of paper and fold it into the shape of a tunnel. Then, blow through the paper tunnel you've created. After that, observe clearly the effect of the airflow on the tunnel. The next part of this video will show you an example of how this experiment should be done. As you can see, after blowing through the tunnel, the paper moves closer to the table instead. Why this happens is because the air that is blew below the paper moves faster than the air on the surface of the paper. Thus, the fast flow of air causes low pressure below the paper.
The slower moving air on the surface of the paper causes higher pressure. This high pressure pushes the paper closer to the table.
The principle that is applied in this experiment is Bernoulli's principle, which states that when the velocity of a fluid increases, the pressure in the fluid decreases, and vice versa.
Now, let us move on to part 3. Bernoulli's principle has stated that when the velocity of a fluid increases, the pressure in the fluid decreases, and vice versa. The activity that we are about to conduct today will show you how the flow of water at high velocity produces a region of low pressure compared to the pressure of the surroundings. The pressure difference produces a force that acts from the region of higher pressure towards the region of lower pressure. Therefore, the higher atmospheric pressure around the serial will push it to the area of lower pressure, which is towards the stream of water.
Now, we would like to demonstrate how this activity should be carried out. The first item that you will need is a plate, some cereals, and water. To carry out this experiment, we first have to float 2 cereals in a bowl of water about 2 inches apart. Then, pour in some water in between the cereals. They will float next to each other. The result that we can see now is that the 2 cereals are floating next to each other. Therefore, the Bernoulli's principle explained earlier is proven.
That is all from us. Thank you!